So hello, everyone. I'm Susan Nash, and we're in one of our presentations for our GEODE AAPG Subsurface Characterization for Geothermal Energy webinar and series of presentations. And I'm really thrilled to be able to introduce Joe Batir of Teverra. Joseph has been doing a lot of work in geothermal for a long time. He graduated from SMU. And then one thing that has been quite interesting, I've had the opportunity to see at least two presentations at OTC on offshore geothermal exploration. So it's really interesting, lots of potential. So we'll learn all about that. Just want to remind everyone that you will be receiving an email with a link to the recording. And also you will receive a separate email for yesterday's set of recordings. So anyway, happy to see you here, Joseph, and thank you and welcome.
All right, Susan, thank you for that introduction, and thank you everybody for taking your lunch hour to listen to Offshore Geothermal. So I think the talk that was just before this, talking about abandoned wells and repurposing, is a good segue into offshore geothermal. And things that I'll be touching on are the idea of repurposing versus drilling new wells, and also big picture, what is the opportunity and how do we know the opportunity? The reason I'm talking through this right now is because I realized I did not add an outline to my presentation. So we are just kind of going to jump right in. And with that, I know Susan just gave an introduction, so I will not harp on this too long. If you do need to grab a screenshot of my email, here it is. And as Susan said, Ph.D. from SMU. I have kind of worked all over the place. Today we're going to focus on Texas and the Gulf Coast. And so let's go on to geothermal and offshore geothermal energy. As a quick refresher, since we just had this, I'll go fast here. Remember that energy use, and specifically geothermal energy use, is not just power. There is heating, cooling, electricity, and a lot of uses in each of those. So the question that I want you to be thinking about as we jump into thinking about the offshore environment, and hopefully some of you in the room have experience offshore. My experience comes from my desktop. I've never been to a platform. I've never seen all of the inner workings of those small little isolated cities in the middle of the Gulf or the North Sea. So really, I ask this question genuinely: what uses of energy exist offshore? Is there heating? Is there cooling? Are there electricity needs? And how could geothermal fit into those? So there's that question. And then the second question is, what uses will be coming up in the future? Next week is the Offshore Technology Conference. So I think this is a good time to preface this as a refresher, and also point out I will be at OTC if anybody else is going to be there and wants to follow up on this in a more one-on-one conversation. But as we think through the blue economy, as we watch all of the North Sea and Arctic vessel lines for global transportation and global shipping lanes open up, this question of what energy uses in the blue economy, this becomes a larger question. And it becomes a more important question because there is more opportunity for shipping and more opportunity for globalization with things like the Arctic Sea opening up. So thinking through geothermal as part of the blue economy. I want people to be thinking about that as a big picture idea. What is offshore geothermal? When we think about offshore geothermal energy, we the starting point for me is, and I'm getting somebody adding some lines on here. So just as a reminder to all participants, I think we're supposed to hold questions until the end, and if you have a question on a specific slide, just make it a notation, and I'll go back there, and then you can add annotations later if it's still necessary. So, what is offshore geothermal energy? Geothermal energy in an offshore or nearshore environment is what we're talking about here. When you look at this figure on the right, this is a kind of all-encompassing figure of volcanic environments and major plate boundaries and what types of boundaries those are. And you can see that there's a lot of plate boundaries, primarily rifting centers, but then some other transforms and convergent boundaries in the offshore and nearshore environment. There's also a lot of geothermal energy and geothermal opportunities in these volcanic settings. So the big question here is, how do we utilize and take advantage of those opportunities? So there's significant potential offshore, potential geothermal opportunities. And this is in quotes because it's a known tectonic or geologic setting where there is going to be a high amount of heat and energy. Question is, how do you produce it? And what I am proposing is looking at utilizing existing oil and gas expertise and infrastructure in these offshore settings. I recognize that most of the talk is going to be focused here in the Gulf of Mexico. So this is not an area where you have traditional geothermal energy production, which is going to maybe put a bit of a damper on this conversation. But I think it's important to utilize that because that's where we have the data and that's where we have expertise. So keep that in mind as we talk through it. There has been a significant amount of I'll call it thought experiments around offshore geothermal energy. And these go back over 20 years ago. This figure that I made on the right is from 3 different papers looking at different ways of thinking through how can we produce all of the geothermal energy that exists offshore. These all focus on volcanic settings. So in a volcanic setting, you have that known resource. The resource is technically close to the surface. And then another benefit that exists here is that you have the potential for super hot rock. That being a potential because you are in a volcanic setting. The main areas where this kind of work has taken place is Iceland and Italy. I do want to highlight and emphasize that to date, no wells have been drilled specifically for geothermal energy production in an offshore setting. There have been a significant number of IODP wells, and the International Organization Drilling Program, maybe. I think I'm wrong on that. But it's the IODP wells are all scientific drilling wells to understand geology, tectonics, and put an idea and understanding to the offshore environment and the formation of the earth. They're not specifically targeting geothermal energy production. So they help us understand the opportunity and the potential, but they are not, we shouldn't, as we pointed out in the last talk, we should not be looking at academic studies to define economics of opportunities. Now, looking at this figure, I'm focusing on the resource potential. This is more just to show how to produce offshore geothermal energy. It's been thought about either as a floating platform, drilling directly into a seamount, having a turbine and electricity generation at the seafloor, and then also thinking about that seafloor, a floating power plant on either stilts or a floating platform, as well as thermoelectric power generation right at the seafloor as well. So people have been thinking through how to do this in many different ways. The key point is that we still don't have that energy production yet. So that was volcanic settings. We have also seen studies in sedimentary basins. Now, sedimentary basins are interesting from a geothermal energy perspective because there is mature engineering technology. Here we've got the Gulf Coast into the Gulf of Mexico, and then we have a figure of the North Sea. These are areas that have decades of engineering expertise and very, very high level, very technical, very specific engineering because the offshore environment is a high stakes environment. There is also significant data. Looking at the map, every single one of these points along the Gulf Coast and into the offshore environment, each of those are wells that have data here so that we can plot them. There is also that mature infrastructure component. There are platforms. There are under at the seabed transmission lines for piping as well as some areas for power, depending on how far offshore you are. The one downside here is that these areas do have a limited geothermal resource. When you look at these data points, and we'll look at this figure again, the oranges and yellows and reds, those are the hottest temperature points. You have less of those offshore. When you look at the map on the right here, this is geothermal gradient. It's kind of the same. Reds are the areas that are of most interest. There's really only one especially hot area, and then there's a few areas that kind of show up for the North Sea. So while we do have one side of it, all of the development and supply chain logistics and infrastructure in place, we don't have as good of a resource. So now we're gonna start zooming in on the Gulf of Mexico. So the Gulf of Mexico, it's an area that has been studied for decades, specifically for geothermal and associated with geopressured Miocene and Oligocene sands. This is something that came out of, first started in the 80s, looking for energy opportunities that would be able to, kind of similar to today, utilize the existing expertise and know-how and infrastructure that was in the Gulf Coast from the oil and gas industry, and utilize those to produce geothermal energy. In the 80s, this was all associated with the oil embargoes at the time. So this is something that has come out of that and has been of interest ever since, mostly on the onshore side. So we are going to take information from the onshore environment and then slowly move it offshore. And a lot of this is as Susan pointed out, this will be a conglomeration of several different talks that my team and I prepared, mostly to present at OTC over the past few years. And this is kind of a large summary of all of it, thinking through how do you actually develop geothermal in an offshore environment. So talking about the US Gulf Coast, geopressured systems. There have been onshore studies that are highlighting these large geopressured fairways. These geopressured fairways have elevated geothermal gradients within that geopressured formation. So what you end up with is average normal gradient going down to this geopressured zone, and then you have an increase in the geothermal gradient. That increase in geothermal gradient means for the same amount of drilling, you end up with a higher temperature. You have a higher temperature resource at a relatively shallower depth. And then you go back to a normal gradient below. This is what the data shows us. Within that geopressured zone, you also have a what you would see when drilling is a pressure kick. That pressure is also potential energy that you can also produce from this. So this increased potential, you have this increased potential here, but that also comes with additional production challenges. And those additional production challenges are not going to be the focus of this conversation, but it is something to consider, similar to the last talk where you've got deep, hot fluids, and usually those deep, hot fluids have higher TDS, or total dissolved solids. Similarly here, in these geopressured formations, because they're geopressured, and then you start producing that and depressurizing, you have different reactions that start to occur, both chemical and physical, that make these systems harder to produce. There was a 2-year long production test associated with a well in Pleasant Bayou, and that information, it was funded by the DOE. All of that information is publicly available. We're not going to talk about it anymore here today, but those, I actually covered those in some of my last presentations. So with that increased potential, there is additional production challenges. What I want to highlight is the optimistic side. As we move offshore, so you have this elevated gradient. That elevated gradient in this geothermal gradient data would show up as individual high temperature or high gradient data points. And notice the kind of along coast trends where you're getting the larger sand deposits, as you would expect. You have those same trends as you move further offshore. So the likelihood of additional geopressured zones that are opportunistic for geothermal energy production do exist offshore. And then you do have kind of random data points as well that may also be greater opportunities for this offshore geothermal energy production. The point here is that there is data, there are resources that the data points to, and so it is worthwhile to keep thinking about how do we do offshore geothermal energy. So going from there into this specific case study, not a cast study, case study. And to give you a big picture viewpoint, for all of our studies, we first go through that data cleaning and characterization. We build thermal models from that data, and then we go through a data analysis on what's available, what do we need to do a proper understanding and a proper reservoir characterization for probability mapping and common risk map building, and then use that to do data-driven decision making. We'll go through this same kind of process here, but it'll be a little bit more focused based on what exactly we are looking for. And so we're we're going to think through this for the Gulf Coast as new drill versus repurposing. Things to think about here. As we look at a new drill versus new drill being on the left, kind of an idea, versus repurposing wells. That was our first kind of big picture question, because that drives what data we look at. Do we want to do a new drill? A new drill can be a fit for purpose well. That fit for purpose well can then be fully optimized so that you end up with the maximum amount of power production. The maybe challenge with that is that it is going to be higher cost from a CapEx perspective, and it is going to, in an offshore setting, this would be a first of its kind. As I said at the beginning, no wells have been drilled in an offshore setting for geothermal energy production. So far, any studies or looks have been either repurposing or have been scientific drilling wells. So a new drill, while maybe the highest energy production, it is also the highest risk, potentially. So what about repurposing? Repurposing, then you are utilizing existing infrastructure. You are able to look and find the data points or the wells that are in the right temperature, that do have the right flow rates. So you're able to opportunistically choose what you should be looking at and what areas are most beneficial. Now, of course, the challenge here with the repurposing is that you are now utilizing the data that's provided and utilizing the wells that were originally made for oil and gas production. They're not going to be fully optimized for electricity. They were optimized for oil and gas. There's a handful of different challenges, but the most important part here is that oftentimes those are smaller diameter, meaning lower maximum potential flow rate. And with that lower maximum potential flow rate and where they're being drilled is the oil and gas reservoirs, not necessarily being drilled targeting high water cut and high water potential. So just things to keep in mind as we are looking at this first idea or first of its kind offshore energy production. So the first phase of this really took place about 3 years ago now, thinking through what could we do? People want to know, is there offshore geothermal energy opportunities? So what we did is we asked, okay, well, what is the most important part when it comes to energy production, especially for geothermal? It's temperature and flow rate. Can you find temperature and flow rate publicly available anywhere to do a first order site selection? The answer is yes, you can find these data. And so that first phase or that first iteration on examination was, what is the flow rate? What is the temperature? Looking at depth of wells, maximum flow rate, last production flow rate, and then also maximum temperature. These are wells in 2 locations. This is I want to say, well, it's Galveston Bay, and then I'm forgetting down here, but these are in bay settings, near shore environments, and Texas offshore state waters is what these were considered. And we saw that as a first step, as a first opportunity, because it overall, from a regulatory standpoint, it seemed like the least red tape. looking at the maximum flow rates, and this is barrels of water per day extrapolated, and then maximum temperature. There's really one or two wells that stick out. Here we've got one that had maximum water per day of almost 120,000 barrels, maximum temperature of 217 Fahrenheit. We also had other temperatures in the 250 to 275 range, but those also had lower flow rates. So this is interesting in that you've got relatively high temperature and high flow rates comparatively on par with geothermal energy wells. So here's an area where we can look at, is there an opportunity that the wells look like they have sufficient energy flow rates to produce electricity? Another big point here to take away from this is that here we examined a handful of wells. This is just the top wells that we looked at. For these two bays, we went through about 60 to 100 wells. So there's only about 5 to 10% of wells that have sufficient temperature and flow rate. Some people estimate 1 to 5% for kind of big picture, all oil and gas wells. So in the offshore environment, I think maybe in Texas specifically and where we're operating in the Gulf Coast, that number's a little bit higher. But this is a good thing to consider and think about as we're talking about repurposing existing wells, abandoned wells, what have you. About 5 to 10% of them are going to have the potential for sufficient temperature and flow rate. We expanded that to Gulf Coast wide opportunities. So not just looking at those onshore wells, but if we go further offshore, and here we're just looking at flow rates, and then we did a depth cutoff. So if you go further offshore and start to look at the ones that presumably would be deep enough for the temperatures needed, as well as having the flow rates, here the minimum flow rate, I think we set at 40 gallons per minute, and then we just included as high as they would go. Of all of the Gulf Coast wells, Gulf of Mexico wells that had publicly available data, we were able to find 46 that had quote unquote high enough flow rate and generally deep enough. Many of these are groups of wells in the deep offshore. Maybe that's an opportunity for local hybrid platform development. And those are examples here, these 3 gas or oil wells. These are all really from the same platform, same as these 3, same platform. We've got 3 wells, high flow rates, all going into an individual platform. Now, you may have noticed we were talking about barrels of water per day. Now we're talking about oil. So this was this is a secondary step where we are, the flow rate is high enough. The question is, because these are oil now, are they going to have a similar amount of water production? Or is this an area where looking ahead, you have to wait until these wells water out and then you turn them on to geothermal production? These are kind of those bigger questions that we'll think about later on. So looking at these numbers and these temperatures, kind of 200 maybe to 275 and relatively low flow rates, what kind of production are we going to do? Okay. What kind of production are we going to do here? More than likely, these are going to start with existing wells with a common tieback, one single platform. Some of these are higher temperatures, so medium to high temperature wells with temperatures in the 270, maybe up to 350 Fahrenheit, and moderate flow rates, ideally 10,000 to 20,000 barrels per day. Some of those wells that we were looking at in the nearshore environment had about 5,000 to 10,000 barrels per day. Any of those will generate some amount of electricity. The question is it useful? The most important part here is that with these and with this offshore environment, an organic Rankine cycle power system is going to be what makes the most sense for the temperatures and the flow rates available. And I'm pretty sure the organic Rankine cycle was discussed either yesterday or earlier today. So if you do need a refresher, I suggest you go back and look at the previous talks. I think Eric said he was going to cover some of that. So this is how we're going to produce, and these are the numbers that we're kind of generally looking at. So if there we go. So if we think about geothermal power production from a repurposing power potential, there's two kind of big picture viewpoints. There are two that we start with as kind of end members. There's average production potential in the 80 to 300 kilowatt range. This is utilizing the publicly available estimated flow rates. This is what the wells, quote unquote, water out to. This is the kind of flow that you get from those. That would take two modular ORC systems. Now, if we try to maximize production, maximizing production means potentially putting in an electronic submersible pump, keeping those wells at a maximum production rate, kind of what they looked like at the beginning of their lives. This would probably require some type of additional pressure support for the reservoir. So one thing to think about is how much is this workover going to cost? Because that's another big question that we have to think about as we look through this big picture. But if we maximize power production, now we can start thinking about a singular, larger, optimized organic Rankine cycle system. So even though we're not changing the wells, we are going to maximize their specific production and their production ability. And now we can at least modify and optimize the topside infrastructure. The question that we asked and went through is, are these economic in terms of, is this amount of power production going to be economic in an offshore setting? And how much can we spend building and optimizing the system? So now let's talk about the economics a little bit. And let me see if I can turn this annotation off. There we go. Okay. So economics. What we did for the economics on these two different development scenarios or power production scenarios, we did a very, I'll say this is a simplistic net present value calculation. It's not that simple, but it is broad because there are a lot of unknowns in this analysis. The assumptions we made are that these are 20-year payback systems. So these are going to be in place for 20 years. Discount rates of 0, 7, and 10%. So 3 different analyses. The cost to install the power is anywhere from $2 to $5 million. So we examined this this 2 to 5 million as a function of how much power we were installing. And we examined this as a high and a low. So a high value and then a low value. So we kind of looked across the board there. We also had a flat rate of $2 million per well recompletion. And then we also had a modified accelerated cost recovery system, or MARCS, for the financial people in the room. Now here we did no additional tax incentives. This work originally was started prior to the IRA, or the Investment or Inflation Reduction Act. The key here with the additional tax incentives, I think that as we look at how tax incentives change on a kind of 2-year cycle, there is a need here to be economic irrespective of tax incentives. So what we wanted to model is, you could call it worst case scenario, or most realistic, or most conservative scenario. That's why we didn't look at tax incentives, because if we can do a project without tax incentives, then we know we can do the project. If we require the tax incentives, then there's additional steps and additional analysis that's necessary to decide if you're going to move forward with that project or not. And as I said, the main takeaway, or the main result that we were calculating, was net present value. We did this versus cost of avoided electricity and power production rate. So the cost of avoided electricity in the offshore setting, most of these are, if we're far offshore, we are in an islanded setting. So we are using the geothermal energy, either replacing the natural gas or potentially diesel energy that's being generated on the platform. If we are in a nearshore setting, potentially those are hooked up to the grid, in which case we are just offsetting the standard electricity rate. And then power production rate is, we were looking at how much power was being produced and how that impacts the overall total potential here. So on the left side, looking at low production versus the right side being high production. The left side with net present value versus power production rate. And I've added a line here for the net present value of 0, this red dashed line. It's important to note, for the low production rate, anywhere from 0 to half a megawatt, for a 7% discount rate and a 10% discount rate, it's basically negative. For a 0% discount rate, anything above 0.2 megawatts is likely a net positive investment. Now, how often can you use a 0% discount rate? That, again, is for the financial analysts in the room. But it's really just there as a baseline, something for you to look at. What's more interesting is as we get to the high production. Now, high production, we looked at anywhere from 1 to 3 megawatts of power production. We still use the same assumptions as far as cost per megawatt for installed capacity, and 2 million for the well recompletion. Some of those may change if we are trying to optimize power production, especially if we're buying new electronic submersible pumps and installing those. That may change that cost. But here, when we look at something like a 7% discount rate, now almost all of them are net positive. And even for the 10% discount rate, you start to get a net positive value. Now, this is versus avoided electricity cost, this starts to say for a 7% discount rate, really any type of electricity cost, even down to $70 a megawatt hour, you can generate positive value. For the 10%, it really starts to break even around $90 per megawatt hour of avoided electricity cost. As we look at an onshore or nearshore environment where electricity is going to be dependent on the grid, I think this becomes more interesting because we're going to continue or potentially continue to have increasing electricity costs. So the idea of geothermal energy becomes more and more appealing. In an offshore environment, it really is dependent on what type of electricity generation you're doing and what additional factors are going to come into play as we talk about tax credits. What about a carbon tax? Is that going to come into play at any point in the blue economy? So those are the kind of questions that are long term, and where and how these kind of figures begin to get modified to see what is and what isn't economic. One other kind of big question, and really I think is the important part to ask: the economy of scale. As we get into bigger systems, do we need a larger system in order to be more economic? So that's kind of the next step here. This is all repurposing of wells. And for repurposing, the main takeaway here is that we really do need to be in that megawatt scale. And single digit megawatts maybe works if you can find the use for 1 to 3 megawatts or more on an existing platform with existing infrastructure and existing missions. That kind of energy value could work for an economic project. Can we make something bigger? Can we make something that is a new drill? Because that is where we start to talk about setting up new systems and kind of future economy pieces of the economy. So what about economic potential of new wells? Well, this is where the offshore engineers in the room can really start to sink their teeth in. The investment is going to double or triple when we start to talk about offshore new well development. This is going to be drilling of at least 2 wells. If we're talking about a brand new platform, that isn't really included in this. How much is a brand new platform going to cost as we put one of those in for this system? If we're going to drill 2 new wells, this could be upwards of $300 million for that well pair. With these current energy density estimates for those wells, if we're mimicking the offshore geothermal well or the offshore oil and gas wells of today, we're only looking at 100 kilowatts to 5 megawatts. To add a comparison, a typical onshore geothermal well costs $2 to $5 million per well, and those wells have kind of 3 to 30 megawatts of energy coming from them. So here we're talking about $25 million in an offshore setting for 5 megawatt, or sorry, let me rephrase that. $25 million for 5 megawatts of power production onshore. In the offshore setting, $300 million for 5 megawatts. That math doesn't work. What we would need from a well doublet pair is 50 megawatts of power production. That is what makes a $300 million investment to drill those wells. That's what makes that make sense from an economic standpoint. An interesting part here is that That's a similar cost range for well decommissioning or well decommissioning and offshore platform decommissioning. So can you get 50 megawatts from a well doublet? If you can't, does it make more sense to decommission a platform, an offshore platform, as opposed to trying to convert it to a geothermal platform? It's a it's an important piece to think about. And then when we look at the 50 megawatt number, where do we see 50 megawatt geothermal wells? We see them in places like the Imperial Valley, which is an active spreading center. We see them in places like Larderello, Italy, where we've got a an active volcanic arc. We see them in places like Iceland, where again, we have a hotspot and an active spreading center. So where we can get 50 megawatts of power, really what I'm getting at here is we need super hot geothermal type settings where we can get into superheated steam and supercritical fluid production. There's a lot more to that I'm not going to address. I think the point here is that 50 megawatt well in a offshore sedimentary basin setting, it's going to be challenging to get to. So we're in an economically challenging time today with the existing technology to make it make sense for new wells to be drilled, especially in places like the Gulf of Mexico for geothermal specifically. But it it doesn't mean that it's not possible technically. It just means it may not be economically viable today. So big picture, how do we make it economic? Well, simple. You increase revenue and you decrease cost. How do you increase revenue? These could be co-produced wells, so oil and gas production, and this could also be on the platform itself, not necessarily just from those specific wells. And it could be a long-term, as I said earlier, there's wells that maybe that 10,000 barrels per day is the oil well watering out. Maybe you've got 10 years of oil production, and then you plan in another 10 years of geothermal energy production. So adding new revenue streams, oil and gas production, wind, carbon sequestration, offshore, or potentially hydrogen or lithium production. Really the big point here is finding ways to tie into the blue economy and ways to feed into that. And then you have to think about ways to displace or decrease cost. One of the biggest costs when we talk about offshore energy is platform decommissioning. Right now, plugging and abandoning wells is a large discussion in the onshore space in decommissioning. This is a significant cost that ultimately we need to plan for, but we can defer it. And if we're deferring it with purpose and with intention and have a plan for decommissioning later, I think it makes this could be something that is a valuable input into the economic calculation. More realistically or more tangible, does the geothermal create cheaper electricity? I recognize I've been saying we don't utilize tax credits in our calculations, but are there tax benefits that can make this more economic? And is that something that you can pick and choose which ones you want, especially if you've decided that you don't need them for an economic project? Other big points are horizontal drilling. Currently, the average lateral length for all wells is 18,000 feet, according to the EIA. Maybe horizontal drilling increases the value and the net energy production per foot or per dollar from a well. Maybe horizontal drilling is the way to make these ultimately more cost effective. So I know I've gone through a lot here. Feels like a lot of rambling. So I just want to try to wrap this up a little bit. How to do exploration and thinking about this with offshore geothermal energy in mind. The first step is establishing the goals. In this scenario, which we just walked through, it was offshore geothermal energy production. From that goal and understanding the goal, determining the workflow and or collating data. I have this twice in here, and that's with purpose because sometimes the data is the first thing you do. Maybe the data is the defining factor. You can only get so much data, and based on the data available, you define your workflow to then produce your results. Or maybe you can define your workflow and then decide what data you can collate, what data you can collect new. So determining workflow and collating data, kind of an iterative process with producing results coming after that. And remember, those results should be going back to what is your goal? Here, determining is offshore geothermal energy production technically possible and also economically viable. So produce those results, and from those results, then determine next steps. So is offshore geothermal energy viable? Well, to start off, this is not a new concept. It is still in the concept phase, though. I think the primary limiting factor right now is project economics. One of the main challenges here is if we're talking about repurposing, this is going to require 10 to 20 years of project life to get to a positive net present value. That requires thinking through the first phase of the life of the well and then another 10 to 20 years. If we're going to drill new wells, the challenge is energy density. We need something on the order of 50 megawatts per well doublet, in order to make drilling those costly offshore wells pencil out. Now, I do feel like these talks are pessimistic as far as offshore geothermal energy production. I don't want to leave you with that. I do think offshore geothermal energy is a good idea. The question is when, and it's maybe not today. Maybe it is still something to think about in the future or something to plan for in the next 10 to 20 years. And I say this because repurposing wells can extend the life of the existing infrastructure and existing assets. I think there are ways to make it economic, and there are ways that is valuable. A simple net present value calculation on just the geothermal, that doesn't look that good. But what does that geothermal energy unlock for the rest of the platform? That is the real question. And that is maybe where the value is. It's not the energy itself, it is what the energy unlocks that is the value. One thing that we didn't touch on, but thinking through this more with the repurposing of infrastructure, offshore energy storage may be a significant economic viability, may have the most impact as we talk through big picture offshore wind farms, long-term, what the blue economy looks like. Maybe taking these wells and using them for energy storage becomes the most valuable component. So I'm going to leave it at that. This is the end of the presentation. I'll leave it up so that way I can easily flip to 2 slides for questions. And I've been seeing everything coming in. So ready to discuss. Susan, are you going to come back on screen and unmute?
Oh, wow, you've finished up really early.
Did I? I thought I was at 1:15.
Oh,
I guess maybe I did.
yeah. Anyway, well, yeah, our next one is, let me look at the schedule. Well, if you'd like to look at some of the questions too. Yeah, you were
Yeah.
from 12:30 to 1:30. So our next one is at 1:45.
All right. Well, we can go through questions, and then there is plenty of time for everybody to grab lunch.
That's right. Yeah, if you just want to go through a few of the questions and then or we could just, if you've covered most of them, that's fine too.
Yeah. So I can just start going through them. So there's one by Lena Broadley asking about what about offshore geothermal in places proximal to offshore wind farms? That is a yes. So when you think about a well, let me go to when you think about the economics of drilling new wells and thinking about 50 megawatts of power in an offshore environment, where would you actually use 50 megawatts? That that's I think an important question. And that's something again the offshore engineers probably have a better handle on, because I don't know how much power a traditional oil and gas platform uses, a platform of today. So 50 megawatts, maybe you can't use all that on a single platform, and it makes sense to tie it back to onshore. So when you've got gigawatt scale offshore wind farms being developed, it almost makes sense to co-locate those with geothermal opportunities so that you do have a tieback to the onshore environment. And that does also add additional value to the wind, because now even if it is a, call it 10 gigawatt wind farm, you still have some amount of firm power that can add additional value to the wind farm itself. And yes, to Patrick, the second well location is Corpus Christi. Thank you for marking that. So now, are you assuming production decline with time in the economic model? For Dinah's question, the production decline, no, we are not assuming any production decline. The models assume that is a constant rate. This would require pressure support, and I think that is one of the aspects that is important to think about, that all geothermal systems require a high level of reservoir management, because the pressure support is so important in them, so that if you do proper reservoir management, you drill less wells, and those less wells ultimately mean you have less operating and maintenance costs. So right now that is not worked into these production models. but it is an important point. So the next question from Harold. How is fluid cooling over the project lifetime considered in your economic analysis? Are you assuming a constant fluid temperature? Is this assumption realistic? So for Harold, there is no fluid cooling associated with the modeling. Is that assumption realistic? Yes and no. When you do the reservoir models, and that is a full 3D thermal flow model. When you do a reservoir model like that, you can model wellbore spacing and wellbore flow rates so that you have minimal fluid temperature loss and you have minimal thermal degradation in your wells. And so that you don't have that short circuiting connecting your injection well to your production well. That level of detail with the 3D thermal modeling, that was not done with this work. This is very early stage and really more of that big picture thought experiment of let's take the existing data, do some first order calculations and determine, is this worth doing a larger feed study, larger economic investment to decide if this is a viable business opportunity. So the assumption is realistic if you do that 3D modeling in this scenario, and depending on how you decide to do your reservoir management, there could be a likelihood of thermal degradation in your field. One side note with that is that there are studies onshore, long-term oil and gas fields in East Texas, where you actually have temperature increasing in the oil reservoir, and that's because you have a slow enough flow rate and production rate that you are drawing up heat and you're drawing up hotter fluids from below. So it's a sample set of one, but depending on how you actually do your reservoir management, you don't necessarily always have cooling. Now the question from Bara, how would the bottom hole temperature corrections be done? Specifically, what would be considered for the ambient environment temperature, air temperature onshore? So you do it in a similar way, whatever bottom hole temperature correction you want to use, and then you should set that to your the base of the ocean bottom, and it's probably 1 to 2 degrees Celsius. Rex's question: have you compared NPV between repurposed and new wells with respect to casing, perforated slot liner diameter, and geothermal reservoir depths? No, we've not done that. That is kind of that second level of detail where a lot of those aspects are you start to get into what does that repurposing and what does that well workover look like. That is where you also need to have an estimate on the cost of the wellbore workover. So we didn't get into those kind of details because that is starting to get into that optimization phase. And here it's more of a, are you above or below a threshold that that is a go, no go decision point of, do you continue on with the study? So now from Dr. Alfred, what are the weight impacts on the existing platform and space requirements for geothermal power plants offshore? Are they similar to those of offshore gas turbine generated power plants? Have you made a comparison? That is a good question. Now, the short answer is no, we have not. I don't have a picture here, but that's another point when we're talking about long-term viability, and when we're talking about jumping to this one, 20-year payback, we really need a dedicated space on the platform to have this power production that is going to be there for 20 years. And where and how that gets put in and how that fits into the larger scale of all of the space and the space real estate on a platform, it's an important question. And that's another one where you have to think through, almost, is it even viable to get an ORC onto the platform? If it's not viable to find space for the ORC, then the rest of it's a moot point. But if you are thinking through utilizing geothermal from the beginning, that this is part of the long-term platform plan, then you probably plan in an ORC location. So this is a bigger question of, are you retrofitting the entire platform, or are you planning for geothermal the entire time? So now Lewis's question, to your knowledge, is there published references on the use or attempt to use of geothermal in an offshore setting? How about SPE? So there are some geothermal publications. I don't think I've got any in. Yeah, I don't have any backup slides. So if you want, you can email me and I can at least share with you our publications. We've got 4 publications that have all been presented at OTC. There was work done in the North Sea, both by Dr. Nolan, who did this work, and then there was also an individual study looking at repurposing a platform that was funded by the Net Zero Technology Office in Scotland, I believe. The results of that work, I don't know if they are public. So that you'd have to do some Googling on. That was, I think, started around when we started looking at the Gulf Coast and Gulf of Mexico. I think I saw an announcement that they completed the work. I don't recall if there was a public presentation or any type of public report that was produced from that work. Let's see, from Jeremy. Lots of interesting questions for Joe. I did not have adequate information to incorporate into the study. So that was some commenting on everything. And as a side note, I realized I did not include any co-authors in here. So Jeremy Boak he did a lot of the financial work. And then our team at Teverra, Emily Gentry, did additional subsurface studies and data collation for this work as well. So now, Lena, could offshore wells be repurposed to store excess wind energy as for power generation during windless times? Yes. So that was something that we did not highlight as much. That was while we were putting this together and starting to look at the future of how to make this economic. Energy storage is something that we work on at Teverra, and we're also looking at how an energy storage system works and where it's most viable. In an offshore setting, storing offshore wind, there's several different opportunities there, because you can, and this kind of goes big picture for all energy generation plus energy storage. You can build your system so that you have excess energy storage, but not so much excess energy storage or excess energy generation that you have to oversize your energy storage. So you can modify and optimize your energy storage plus your energy generation system to be essentially the least cost energy possible. By doing that, you could also, in an offshore setting, modify what your transmission lines back to shore are. So that and that's one of the issues right now with transmission is that we don't have enough transmission. And so this is an area where you could build energy storage instead of excess energy transmission. And maybe that makes the entire system as a whole work better. So those are questions that we did not start to think about in detail. These are the bigger questions that are kind of beyond our subsurface focus. And a lot of this work was subsurface up to publicly known energy generation and calculation estimates. So when I think about this and continuing on that energy storage component, I think this is where you can start to think through combining things like wind with that larger, when we're talking about gigawatt scale, and then geothermal wells that are going to be megawatt scale. You can start to pair and build a larger energy system that has the storage component with it, so you can optimize the total cost. I think there's also a future blue economy component where you've got smaller, more modular setups, call it a single platform, where maybe you've got 1 to 4 wind turbines, and then also two geothermal wells, energy storage geothermal wells. And that ends up being a localized hub for long-term, almost like an offshore gas station. For what? I don't know. I I dabble in the blue economy about 1 week a year, and that's at OTC. And then sometimes I think about it when I write these papers. But this idea of converting platforms into quote unquote gas stations or building specific platforms on supply chain and shipping lane routes, I think this is a very interesting concept, especially as we talk about switching over from bunker fuel in these large shipping vessels and changing those over to things like hydrogen or ammonia. It becomes a larger question of, is it better to refuel more often? Can we develop ammonia and hydrogen systems offshore and essentially build these quote unquote gas stations? Let's see. So the next question from Orkion. Yes, the gas flaring on offshore wells can be combined with the geothermal electricity production. That's another one of those big picture ideas of where and how do you combine all the different waste heat resources and build that into a single energy use. We did not look at that in great detail, and partially one of the things that we did find as we were looking through all of the work is that there are a lot of the newer platforms are using natural gas gensets for their power production. And a lot of those, instead of using instead of having dedicated gas production, many times if there is a section that is going to be flared or a gas that's going to be flared, that ultimately goes into that. So that is partially why we didn't look into that as much, because that's a pretty straightforward opportunity there. So let's see.
Well, I think we've almost, now it's 1:30, so we have moved up our time. I think
Yes.
we have time for one or two more.
Did you see any that are particularly interesting that you want me to answer?
I think you covered pretty much everything. I mean, it's really interesting because it makes us think about the future.
It does. Yeah.
And again, just sort of like, how easy is it to use existing facilities?
Mhm.
And some of the, I mean, just some of the questions we really need to ask as we select candidates and we prioritize.
Mhm. Yeah. Yeah. And it ultimately goes into those bigger picture ideas of what are your goals, your being the companies or whoever's working on it. What are the goals for that platform? And what are the goals for that part of the greater energy industry? So I think there are those kind of big picture ideas that are required to think about as we think about the next 10 to 20 years of energy production.
Exactly. Great. Well, thank you, Joe. This was amazing. So I'm so glad we had so much time for in-depth responses to the Q&A, and that really was a big value add.
Yes, yeah, that was part of the goal, was just in case there were a lot of questions. So thank you everybody for the questions. And if you didn't get my email and you won't be at OTC, you can find me on LinkedIn to ask
Absolutely.
more.
Great. Well, thank you. And we will finish up this one and then we will stop recording right now. Just a reminder, you'll be receiving an email with link to the recordings. And thank you.